All right, so now we're going to be working with solving quadratic equations that sometimes might have what's called complex solutions. All right, so right now you have an equation right here. You need to write this equation down. It says 11x squared minus 6x minus 2 equals 0. That's the first thing you need to do. Write it down, nice and neat. Now, what I want you to do next, after you do this, we need to be able to identify the A, the B, and the C value. A, B, and C value. All right, so right now, remember, we are in ax squared plus bx plus c equals 0. So our A value is 11, our B value is negative 6, and our C value is negative 2. Now, something you need to be aware of is the quadratic formula that always gives you your x value, or your roots, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. All right. But when we're doing the quadratic formula, we always start with the value of the discriminant. And the value of the discriminant is b squared minus 4ac. So understand, if you see this part right here, you'll notice that this part is the value of the discriminant. But the number one thing students mess up on when they're trying to find the value of the discriminant is they forget to use parentheses because they just don't think they matter. But they do. All right. What is the b value? Negative 6 squared. And if you didn't use parentheses, it would become a negative 36. But a negative times a negative is in fact a positive. So this is what students do all the time, and it just drives me nuts to no end. And that's why I have no hair on the top of my forehead. It's because students just don't listen. Watch. Look, negative 6 squared. Look, doesn't work. But if you put it in parentheses, people, that's the purpose. All right, I'll be quiet now. Now I'm back on. So here we go. What's my A value right there? 11. You put an 11. And what's my C value right there? Negative 2. So a negative times a negative ends up being a positive. And so we got 4 times 11, which is 44, times 2, which is 88. Now, the value of my discriminant is the sum of 36 and 88. Just take 36, add 88. What do you get? 124. So this is how you would type it in to your calculator. If you were just using a calculator, you'd put minus 4 times the A value, which was 11 and negative 2. All right. This is how you would type it in if you're using a calculator. Okay. 124. Okay. Now, if you wanted to know the factors of 124, you just put 124 divided by x, check your table button, and you can clearly see the factors. Now, my eyes are being drawn towards this right here. I'll explain why they're being drawn towards it. And it's actually more to do with this 4. I like perfect squares. So perfect squares are like 4 because the square root of 4 is 2. Another perfect square is 9 because the square root of 9 is 3. Okay, so I like the 4 and the 31. So here's what I'd like you to do. I'd like you guys to go right over here to the right. And I want you guys to take the square root of 124, but don't put it in the calculator. We're going to break it down into its factors of 4 and 31. We're going to break down the 4 into a 2 and a 2. We're going to circle this group of 2, because even though you don't know this, you know what number's inside this index even though you can't see it? A 2, because square roots look for groups of 2. They look for pairs. So a 2 comes out, but what stays inside the radical? Boom. So the square root of 124 is actually simplified to 2 radical 31. If you don't believe me, which most students don't, the square root of 124 is this approximate value, but if I did 2 radical 31, you'll still get the same that's how you know you did it right, if these numbers match. This is the simplified version. This is the approximate version. All right. All right. So here's what we're going to do. It says negative b. So if I say negative b, that's going to make that actually a positive 6. Because if I take that negative 6 and plug it in, a negative times a negative is a positive. Then I'm going to put a 2 radical 31 all over 2 times my a value. Well, what is 2 times my a value? 22. You're like, woohoo, I'm done. Not quite. Why? Because there's numbers that can go into a 6, a 2, and a 22. What goes into it? 2. So that becomes a 3. That totally cancels out. That becomes an 11. So here's my final answer. 3 plus or minus the square root of 31 all over and 11. But how would I write this as a solution set? Here's how you would write it. 3/11 minus the square root of 31 over 11, comma, 3/11 plus the square root of 31 over and 11. Like, where the heck did you get that minus and that plus? Right there. Wait a second. Why'd you put the minus first and the plus second, even though it said plus then minus? Because this is the lesser and this is the greater. It would make sense if you subtract something, it's going to be smaller than if you add something. So I'm looking for the answer that looks like this. All right. Like, oh my gosh, it's so much work. Oh. So hold on. There we got 3/11 and square root of 31. Oh, it's this guy right here. All right. Yep, I'm liking it. Go back to the. There we go. Nailed it. Okay. All right, this one's going to go a lot faster, okay? This one's going to go a lot faster because I'm not going to take as much time, but I want you guys, please write this down. We're going to write down 6x squared plus 5x plus 4 equals 0, okay? Now, let me show you guys a little trick if you want to know whether or not it's going to have complex roots or not. You guys see this right here? Check this out. If you guys go to Desmos and you type in 6x squared, okay, go to 6x squared, and it's what? Plus 5x plus 4 plus 5x plus 4. Does this touch the x-axis at all? So we know we're going to have 2 imaginary roots. So it doesn't give you the answer, but it lets you know whether or not you have imaginary roots or non-imaginary roots. All right? If it touched the x-axis, like for example, right here, does that have 2 zeros? Yeah, where? Right there and right there. But if I said plus 4, now we went from having real zeros to having 2 imaginary roots. Here we go. A equals, B equals, C equals. We're going to do this one a lot faster. A is 6, B is 5, C is 4. 6, 5, 4. Next thing we're going to do is we're going to find the value of the discriminant. That's what you always do first. B squared equals, B squared minus 4AC. So we have 5 squared minus 4 times my A value times my C value. So I'm just going to do this carefully in the calculator. If you're writing this down, it's okay. I'm just going to go ahead and do it right now. I'm going to go clear this out. So all we see is 5 squared minus 4 times my A value, 6 and a 4. What do we get? Negative 71. So if you would please put negative 71. All right, I'm going to pause the video real quick. All right, so here we go. We're gonna use the quadratic formula. It says negative b, so I'm gonna put negative 5, which is our b value, plus or minus the square root of negative 71 all over 2 times my a value, and 2 times 6 is 12. All right. Now, This is where students need to understand. If you have the square root of negative 71, that's the same as saying the square root of negative 1 times the square root of 71. But wait a second. What is the value of the square root? Very good. That's equal to I. So I radical 71 is the same as saying the radical 71 times an I. So could you please put negative 5 plus or minus the square root of 71 and put in I right there all over 12. So I'm going to put negative 5/12. Ready? Negative 5/12 plus or minus the square root of 71. I'm sticking the I outside of the radical all over 12. And that's my answer. I'm not going to separate it into two answer choices, okay? That's where the plus or the minus comes in. So now I'm just going to scroll over here, take a look at them. Looks like we got it right here. Looks like answer choice A is the correct answer. 1 second. I'm going to close this out real quick. Go back, see if there's any other questions. Pause the video real quick. So some students had a good question about this and how it got to this. So if you guys would, this should make a lot of sense. All right. Would you guys agree that the square root of negative 5 could be the square root of negative 5 times a 1? All right. But you could also say it's 5 times a negative 1. Now, if you see this, I want you to see that I can actually break it down into that. So here's what I want you to understand. Would you guys agree the square root of 4 can be broken down into the square root of 2 times the square root of 2? The square root of 2 times the square root of 2 is the square root of 4. All right? But the square root of 4 is just a 2 because the square root of 2 times the square root of 2 just becomes the square root of 4, which is a 2. Okay? So how about this? If I say the square root of 34, would you agree that's the square root of 17 times 2 underneath the radical? 17 times 2 is 34. You could also write it like this. The square root of 2 times the square root of, like that. These mean the same thing. So why am I doing this? Because I know from my complex number system that what is I always equal to? The square root of negative 1. So voila, I'm like, okay, this guy right here actually becomes what? I. So we're going to do one more problem, and then you have the rest of the period to do one assignment. Okay? One more. That's it. So if you would please, last problem right here, write it down. 3x squared minus x plus 8 equals 0. This is our last one. And I'll stop making you suffer. Okay? All right, here we go. What's our A value, everybody? 3. B value? Negative 1. C value? 8. We always start by doing B squared minus 4 times my A value times my C value. So parentheses squared minus 4 parentheses. I always set it up. Take the negative 1, plug that sucker in right there. Take the A value, plug it in. Take the C value, plug it in. 1 minus 12 times 8, which is 96. So 1 minus 96. What does that give us? Negative 95. So what is inside of our radical in our quadratic formula? Yeah. So negative b plus or minus. So for the students who are like, I just don't know that quadratic formula, I'll just write it down right there. There it is again. Okay. So we're going to take that negative 95. We're going to plug it in right here. But if I say, wait a second, what's the square root of negative 95? That actually becomes radical 95 times I. And why? Because the square root of 95 times the square root of negative 1, you can break it down, and the square root of negative 1 is the I. So here we go. Negative b. So if b is a negative 1, we're going to put a positive 1. Plus or minus radical 95. I is on the outside all over 2 times my a value, which becomes a 6. So here's your final answer. 1/6 plus or minus the square root of 95 times I all over 6. So, bless you. Student just had a big sneeze. I hope you guys see the answer right there. All right, so I'm going to go ahead and click it right there. Hit check. Nailed it. That's the process that I want you guys to be working on today. All right.